Hello everyone. Today we'll discuss about types of sampling. In the previous session we have discussed about sampling theorem, Nyquist rate, and then the reconstruction of the sample signal. And today we'll extend the concept of sampling towards to the types of sampling. The learning objectives of today's session are to understand types of sampling. There are different techniques that are available to sample a signal. Then the waveforms of the respective type of sampling and the circuit diagram. How to generate these sampling techniques. So here are the broad category of the sampling. It is basically divided into ideal sampling and practical sampling. The ideal sampling is nothing but the impulse sampling, where the sampling signal or this input signal is sampled with the sampling clock is nothing but a train of impulses. The name itself suggests it is an ideal sampling because the ideal signal is used. The impulses that are practically not realizable are used to sample a signal. Hence it is called as impulse sampling. The next type is practical sampling. The practical sampling is divided into two categories, that is two types, natural sampling and flat top sampling. The name practical sampling is given because the sampling signal is having a finite duration of width. Hence it is called as a practical sampling, and these finite duration pulses can be realizable or can be generated using a practical circuits that are used in practice. Let us have a look at these sampling techniques one by one. The first technique is ideal sampling or instantaneous sampling. Here you can see the sampling signal that is used to sample the input signal x of t is using the train of impulses. So here we have the sampling signal is nothing but train of impulses, and after the sample signal, after sampling, the sample signal will look like something like this, and all the sampling signal or sampling pulses, that is impulses, will have the amplitude equivalent to the input signal at that instant of time. That is what is ideal sampling or instantaneous sampling. The circuit is also ideal. It is using a symbolic representation, or using a simple switch we can represent a sampler. So this circuit is called as a sampler. So here the switch is turned on and off at the rate of Ts. Ts is nothing but sampling instant. Okay. This Fr is nothing but rate of sampling. It is nothing but a sampling frequency, which happens to be greater than or equal to 2 omega, where omega is a maximum frequency content of the input signal. Okay. Now at this point we are applying the input signal. The switch will turn on and off, that is, it will be connected to this point, and after Ts interval it will be connected to the ground point. And what you have at this output is nothing but the input signal will be available for this much duration, that is Ts, at every Ts interval, which is equivalent to the input signal. Okay. Now next type is nothing but natural sampling. So here you have a natural sampling waveforms. natural sampling or chopper sampling. Why it is called as a chopper? Because the input signal is chopped, and you can see here it is chopped using a finite width. The width is nothing but it is equal to tau, and the interval between two pulses is going to be again Ts, which is nothing but sampling interval, and it is again satisfies the Nyquist criteria. So here the train of pulses are used to sample your input signal x of t. The circuit, the same circuit here, whatever we have used for ideal sampling can be used to generate the natural sampling. Only thing is here the switch is nothing but a practical device. Normally a transistor or a FET is used to generate the natural sampled signal, something like this. And here you can have the input signal x of t. Here you apply the c of t, that is a sampling signal, which will be something like this, pulses of equal width like this. Okay, and what you have here is your signal is sampled, something like this. Okay. So this is how it is generated. So the transistor is turned on and off. The transistor will turn on and off at the rate of Ts. So transistor will be turned on for the pulse duration, that is with tau, and it will turn off when there is an off period between the two samples, and in that period your input signal x of t, when the transistor is turned on, is available at the output. Hence the shape of the sampled signal, what you have here, is a natural shape of the input signal. Hence it is called as natural sampling.